You have a rough plane, so we know that has friction. It's inclined to horizontal at an angle alpha, and tan equals 3/4. We've got a particle of mass m, so this is our m here, and that's why we have our mg going down. It's placed on the plane and then projected up a line of the greatest slope of the plane. So you can see it's going up this way with the acceleration. It moves up with a constant deceleration. So this deceleration means as it's moving up, friction is slowing it down, which is this F max. And we have the coefficient of friction mu here. So let's break this down. We know tan alpha is 3/4. So we have the 3, 4, 5 right angle triangle here. So we work out sine alpha, opposite over hypotenuse, which is 3/5, cos alpha 0.8. We should just do that out of habit, it might help us later. Now let's start this question. So what do we know? What should we start off with to earn some marks? Well, we know F max equals mu r. Okay? So we can work out r by resolving. So let's resolve perpendicular. R equals mg cos alpha. Yes, this is the r. That's your mg cos alpha, like so. Those are the only two forces acting. That gets you a mark already. We know that we have to use F equals ma, right? That's the total forces acting, so F is not on this, because remember, this force we have here is the acceleration, which is not really a force, it's acceleration of the particle, but it's decelerating as it goes up the plane due to friction. So what do we have? We've got F max, which is going the same way as mg sine theta, so plus mg sine theta, alpha. Now it depends which way we're resolving, so if we're resolving downwards as your positive direction, then that will be F max plus mg sine alpha will equal the mass times the acceleration. So it's got the mass, which is m times 0.8 g, because it's going the same way. Okay, if you're doing it that way. If you are resolving, and this is just for understanding, as that way is the positive direction, so we've got minus F max minus mg sine alpha equals minus, now I shouldn't use just a fraction there, 4/5 or 0.8 gm or mg, it doesn't really matter, like so. Now that's because if you think about it, if we're resolving this way, but the acceleration is actually negative as given by the question. Okay, now if you times this top one, both sides, by -1, you can see that they're both the same. So it depends on what you prefer. So once you've got that, it becomes quite easy. So I am going to get F max on its own, and I can use either one of these as long as you're just resolving. So I'm just going to use this one here. So you can see F max equals, I'm just going to use it as a fraction, 4/5 mg, just because we should go in alphabetical order, minus mg sine alpha. Now that bit should make sense. Now we know F max equals mu r, and we do know what r is from this question here. So 4/5 mg minus mg sine alpha equals mu mg cos alpha. Now I'm going to do a line here to break up this space and change colour. Okay, now it's asking us to find mu in the question, so we rearrange here and we just need to divide out by mg cos theta, alpha I mean. So we get 4/5 mg minus mg sine alpha all over mg cos alpha equals mu. You can see that we divide both sides by mg cos alpha to isolate mu. Now you might think, oh, but we've got sine alpha and cos alpha, but we've worked it out here. So we just plug, what we can do is, as we're dividing everything by mg, now that cancels out. So what we end up with is 4/5. We know sine alpha is 0.6, but I'm just going to say minus 3/5 all over 4/5. Do that on your calculator or use the decimals and you should get 0.25, and that will be your answer, 6 out of 6. And you all could do that, I believe. Now I'm just going to show you how you get your marks. So like I said here, just this bit gets you a method mark. Resolving parallel to the plane, you're going to get a method mark for trying that. Now getting either one of these, I mean in the mark scheme it says you have to do it like this, but it shouldn't matter by direction. That will get you your answer mark. Writing f equals mu r gets you a method mark. So we can all do that. Produce an equation using your f max, which is here. So that gets you your mu, your method 1, and this will get you your answer 1. Okay, and then that's not too difficult. Now, what I would suggest is go back to the start of the video. Can you do this question from the beginning and get it perfectly right? Okay, now a common misconception is you thought this acceleration was a force. It's acceleration, it's different. You do not include that in your formula of your F equals ma here, okay? Right, this is a big 13 mark question, and there was positives in that we're getting some marks. So you've got two packages A and B, each of mass 3 kilos, attached at end of the rope. Initially A is held at rest on a smooth fixed plane, so no friction, at an angle theta to the horizontal ground, where sine theta equals 2/7. Now, I'll let you pause the video and read this question yourself, but the pulley is modelled as small and smooth, so no mass and no friction. It's parallel to the greatest slope of the plane. Package B hangs freely, and we have the skills to get some marks here. So the strings are taut under tension, modelled as particles, and it's a light inextensible string. The magnitude of the tension in the string immediately after the package are released is T newtons. Find the value of T. Right, let's label this diagram. So we know tension must be acting like so. That's your T and your T. They're going to be the same. We've got 3G acting here. Let's just do this out of habit. Opposite over hypotenuse, like so. And using Pythagoras, we could work this out, but let's see if we need to use cos theta and tan theta, because we might not need it yet, but we can work this out using Pythagoras, this length, and work out the exact values of cos theta and tan theta. Right, find the value of T. So this is package A, package B. Let's do the motion of package B. So let's write down motion of B to get some marks. it will be preferable we start writing that down, or motion of B, so it's just clear to the examiner what you're doing. And you know, this is just resolving up or down, motion of B, but B is actually going to be falling downwards, so we should do that as a positive direction. So what do we get? Let's do that arrow. We get 3G minus T equals MA. That's using our F equals MA formula. Okay, we know M is 3, so that's actually 3G minus T equals 3A. That, just doing that, gets us 2 marks. A method, and here is your answer. We can all do that. Now motion of A, let's do the direction to show which way we mean it's positive. It all counts. Motion of A. So we have T going in the positive direction. We have T here. So that's T. Let's do our triangle. Now some of you have put your R here, but we're not going to be using F equals mu R because there's no friction because the plane is smooth. A more accurate model would include this. So that's your theta, and so we know this is 3G and it's going to go this way naturally, 3G sine theta, and that is 3G cos theta. We can do that. So that means that motion of A, that's positive, we have this 3G sine theta going this way. That's T minus 3G sine theta equals 3A, because that again is our force equals mass times acceleration. And as you can see so far, we've got 2/7, so that's nice. This is another M1 and A1 mark. That's 4 marks out of a possible 6 already for part A. Now the final point is to find a strategy to find out T. But we've got 2 formulas in terms of T here. Right, now we've got 3A and 3A, they equal each other. So you've got 3G minus T is going to equal T minus 3G sine theta. Okay, because these both equals 3A, so these two equal exactly the same. So let's add T on both sides. So we're going to get 3G equals 2T minus 3G sine theta. And this should almost earn us our method marks. And obviously plus the 3G sine theta over. So we've got 3G plus 3G, we know sine theta is 2/7 equals 2T, and we can from there use our calculator, and T is going to equal 18.9 newtons for your answer mark. That is a 6 out of 6 that I believe we can all get. Part B, find a distance CD. Now this is a tricky bit. At the instant when the packages are released from rest, B is 0.8 meters from the ground, which you can see here, and above the ground, and A is at the point C. So this is called a point C on the plane, and when B reaches the ground, B is immediately brought to rest by the impact with the ground. So B hits the ground, but because of the motion of this hitting the ground, in the subsequent motion, A does not reach P and comes to instantaneous rest at the point D on the plane. So the motion after, that means the motion after B hits the ground, I guess an easy way to explain it, A's still got some momentum, so it'll carry on moving up a bit until it stops. So you need to define that distance CD. This is the point C. So when B hits the ground, that obviously moves, and then it subsequently stops at D but does not get to P. So what do we need to do here? First, finding A will be helpful, which we can use from part A. Remember, this is part A. We can use, so let's start B here. Just use one of these formulas, so 3G, so 3 times 9.8, so I'm just using this one, easiest one, minus that 18.9 equals 3A, and we can just use our calculator to get A equals 3.5. That gets us a mark, and we call that a B1 mark. That's good, we can all do that. Now we need to use our SUVAT here, because the acceleration is constant, and we're going to use v squared equals u squared plus 2as. Now why are we going to use that? Because we know u equals 0, we know the distance is 0.8, and we know a equals 3.5, and we want to know our v squared. So we substitute that in because we're relating to speed, so v squared equals, and then u is 0, so we're just going to get 2 times 3.5 times 0.8, which is going to give us v squared equals 5.6. That gets us another method mark. Now some of you found v, so v here is essentially when c, this travels 0.8, and then the key word is the subsequent motion. So this is the learning point that we missed out, the subsequent motion. So if it's a new motion, when this drops, that means in our new formula u actually becomes the square root of 5.6. So our u squared is actually 5.6, because this should make sense now. A does not reach P but comes into sustainous rest at the point D on the plane. So when it comes to the rest at D, the V is actually 0 now, and that's a little misconception that's costing us. Now, the magnitude of the acceleration, alright, because A is accelerating like this, and I think if you note that down somewhere you get a method mark. Magnitude of acceleration, the direction it's going, is g sine theta. Now, understanding that the magnitude of acceleration is this is a little bit tricky, but bear with me. So if this is falling, right, that motion is what's acting here is 3g going down. Okay, but when it hits the ground, then actually all that's acting on this direction is just g, right, when it hits the ground. So if g is acting down like so, this movement here is related to g, just gravity on its own, which is 9.8, because that direction is sine theta, so that magnitude is g sine theta. And I hope that bit makes sense, and that will, just recognizing that will give you an extra mark. So this is the subsequent motion, so the extra distance, because we know it travels 0.8, and this is the challenging bit that we don't get next to. So we know it's 5.6, because that's our u squared, because we're still using our v squared equals u squared plus 2as here. But as I said, when this hits the ground, then v equals 0 here, minus our acceleration is 2g sine theta times s. Okay, so just to confirm, because at rest the final velocity will be 0, our u squared is 5.6. Now this is going to catch some of us out as well. Why is it minus 2g? G is acting down, because that's the direction of gravity, but the motion is going up the plane, so that means that's going in the other direction, hence that's actually going to be minus. But remember, we use magnitude as a positive value, but in this context that's going to be like so. So we solve that. 5.6 equals 2 times 9.8 times 2 over 7 at the beginning, hence we did not need to do this, mess around with this, times s, that's the distance, and that will give us as s equals 1 once we work that out. So the total distance, that's another method mark, so the total distance is our 1 plus the 0.8 at the start equals 1.8, and that's our final answer mark. Alright, that was quite lengthy, but hopefully you will understand that. Again, try this video from the beginning, but as long as you can pick up most of the marks, then that's good. You know, you'll probably be going for A star if you can ace this question. Okay, now the final part is state 2 limitations of the model that could affect the reliability of your answer. So what this is asking, what's wrong with our model that's going to really affect the accuracy and reliability of our answers. So some of you got 1 mark and you're just misinterpreting this question, and I'm just going to show you the variety of answers that you can have to ace this question. So here are the answers you can have. If the rope is not inextensible, then you cannot assume equal acceleration. Okay, because that means it can stretch. The model takes no account of the sizes of the packages, which some of you wrote down, which is good, you get a mark. And any 2 independent limitations or consequences of the modelling assumptions that we've made, because we've assumed some things. Because can you see the word modelled as a particle, and it's a light inextensible string, and that covers this part. Remember, air resistance is not a good one because that will affect the tension of the string. If the rope is not light, then the tension is not constant, and we do know these facts. Or if the pulley is not smooth, then the tension is not the same size on either side of the pulley, because we have modelled it here as a small and smooth pulley. So I hope that helps you get 1 or 2 marks on that last part, which is actually achievable for you all.